Hello and welcome back to this, what is the final section in chapter 2 on resistance. Now, resistance is a measure of how easy or how difficult it is for electricity to flow through a material. Now, current passes very easily through copper wire because it has a low resistance. However, current doesn't pass so easily through the wire in a filament lamp. Now, the filament lamp has a higher resistance. As a result, it takes more energy to push through the electrons. This energy is converted into heat and light, of course, in the lamp. Now, components with a higher resistance give off more heat. So how do we go about calculating resistance? Well, resistance is measured in ohms, the symbol for which is the Greek letter omega. The resistance of a component is found using this equation. Resistance equals the potential difference divided by the current. As we said, resistance is measured in ohms, omega, and the potential difference, voltage, is measured in volts, V. Current is measured in amps, capital A. So in the circuit here, there's a potential difference across the component of 12 volts and a current through it of 3 amps. So the resistance, therefore, is 12 volts divided by 3 amps, which of course equals 4 ohms. Now, from this formula, we can see that if the potential difference remains the same, a component with a higher resistance would have a lower current passing through it. And if the potential difference remained the same, a component with a lower resistance would have a higher current passing through it. Therefore, for a given resistor, the current increases as potential difference increases. And for a given resistor, the current will decrease as the potential difference decreases. Okay, so what happens to resistance when placed in series or in parallel? Well, in series, the total resistance equals the sum of the individual resistances. There is the same current in each component. The potential difference of the supply is shared by the components. Now, in parallel, the total resistance is less than each of the individual resistors. The potential difference across the components are the same. The current is shared by the components. Now, just a final thing, not all resistors are fixed. That is, they don't all have the same resistance at the same time, all of the time. So the resistance of some resistors can change. Now, resistors are usually made from wire, where the resistance increases when the wire is longer, the wire gets hotter, and the wire is thinner. Now, a variable resistor is a device with a control to vary its resistance. Now, the symbol for the variable resistor is this. So, in summary, resistance is a measure of how easy or how difficult it is for electricity to flow through a material. Resistance is measured in ohms, and resistance equals potential difference divided by current. Resistance can be increased by making a wire longer, or by increasing the temperature of the wire, or by using a thinner wire. Well, that's it for resistance. Join us again next time as we move on to the third chapter, starting with electrical power. In the meantime, if you haven't already, make sure you subscribe to our channel and click the bell to receive alerts when we upload more videos. Don't forget to look for us on Instagram. If you have any comments, feedback, requests, or just want to let us know you're there, leave a message in the comments below or via Instagram. Get in touch with us. There's plenty of ways you can let us know what you want to hear about, what you'd like to learn about. But until then, keep wondering about the universe.